Hi, folks. I'm trying to learn a new bit of software so that I can draw things for you on my iPad and narrate them. So if I mess up on the software a little bit, I hope you will pardon me. I also should tell you I'm working in my kitchen, and so there are normal sounds around the house. So this is from one quarantined class member to the rest. I want to talk with you today about interval class and interval class vector and explain those terms a little bit. I think it's important at the beginning to talk about interval classes. I think we've talked about this a little bit already, and you've read about it in the chapter in discussing unordered pitch class intervals. When you're working with unordered pitch class intervals, you're trying to find the distance between two pitch classes, the closest possible distance between them on the clock face. As a result of this, there are only 6 kinds of intervals. They're the ones that consist of 1, 2, 3, 4, 5, and 6 half steps, because after that they start to be equivalent to inversions of each other. You can visualize that on the clock face, but I'm going to try to explain it to you on the traditional staff. Interval class 1 is the equivalent of what we've already called the half step. So interval class 1 is any interval that's made up of things that are a half step away. So it would be the half step C to D flat, the half step B to C, the half step E to F. Those are all interval class 1. In addition, if you invert this interval from a minor second to a major seventh, remember when we've talked about inverting intervals traditionally, we've talked about them as different. The one on the left is a minor second, the one on the right is a major seventh. But in terms of interval class, they're both pitch classes that can be expressed as a half step away on the clock face. So they are both interval class 1. Interval class 2, then, is whole steps, minor sevenths, augmented sixths, anything like that that consists of 2 half steps if you collapse them to their closest distance on the clock face. Okay? Interval class 3, let me give that a little bit more space to make this conceptually better a bit. There we go. Interval class 3 is then 3 half steps, like C to E flat, the minor third, or C to D sharp, an augmented second, or D sharp to C, a diminished seventh, or E flat to C, a major sixth. All of these are interval class 3. Okay? Anything that can be expressed as 3 half steps. Now I'm going to try moving this page. This may look a little wobbly for a moment. Let's see. Ooh, look at that. Okay. I'm trying to change this a little bit so I can put things on a second staff. All right. Thanks for bearing with me on this, folks. All right. Interval class 4. Whoops, let's not throw too many people's OCD off here. Certainly not mine. Interval class, whoops. All right. Get back to my pen tool here. Thank you. All right. Interval class 4 is, you guessed it, major thirds, minor sixths, diminished fourths, doubly diminished sevenths, things like that. Okay? Interval class 5 is perfect fourths, perfect fifths, etc. And interval class 6 is what we've known as the tritone, the augmented fourth, the diminished fifth, etc. It actually becomes a very logical and convenient thing to think about these intervals not as several different names for the same thing, but a strict number of half steps. You may have actually started with, when you started figuring intervals, started with half steps. We're going to come back to that now. In essence, it's a slightly simpler thing, even though we needed at first to know the traditional names for those. Okay, so now let's talk a little bit about interval class vectors. Basically, interval class vector is a fancy way of taking the inventory of the intervals that are available in a pitch class set. Let me give you an example of that to start out with. Let's start with a plain old garden variety major triad. C, E, G, or as we would express it as a normal order pitch class set, 0, 4, 7. Oops, sorry, wrong thing at the other edge. There we go. All right, so this is a C major triad. It is a trichord, as our definitions for pitch class sets have gone. It's a pitch class set with 3 elements. And within this pitch class set, there are 3 intervals. Between the root and the third, there's a major third. Between the third and the fifth, there's a minor third. And between the root and the fifth, there's a perfect fifth. Okay? So we can express that as 3 intervals, 4 half steps and 7 half steps. Now, remember that when we discussed interval classes, the 7 is the same as a 5, right? Because that perfect fifths are the same interval class as perfect fourths. Here's another way for us to do that. We can start with the 3 original pitch classes, and then we subtract each element in the pitch class set from one another in order to get the intervals between them. If we subtract 0 from 4 and 7, we get 4 and 7. So we include 7 minus 4, that's 3. And so we have one of interval class 3, which is this one right here. We have one of, oops, sorry, that's this one. That's interval class 3, the minor third. And then we have one of interval class 4. That's this one here, the major third. And then one of interval class 5, since the perfect fifth is the same interval class as the perfect fourth. So we have those 3 intervals represented. Let's take a look at it with a different, sorry, get my pen back here, with a different pitch class set. Let's use the pitch class set that we were using the other day when we were talking about the Bartók diminished fifth. The one that started in the left hand, or in the right hand rather, was this one, A, B, C, D. And if we use integer notation for that, that's 9, 11, 0, 2. Now, just for convenience's sake, and I'll show you why it's convenient, we're going to add 3 to each of these and transpose this to C. So it's going to be 0, 2, sorry, 3, I blanked for a second. 0, 2, 3, and 5. Now, let's do the same subtraction bit that we did a moment ago. 0 from 2 is 2, 3 minus 0 is 3, 5 minus 0 is 5, 3 minus 2 is 1, 5 minus 2 is 3, and 5 minus 3 up here is 2. Okay? So, if we look at that, then we see that this one has one of interval class 1. How many interval class 2s are there? There's this one and this one. How many of interval class 3? Just that one. And how many of interval class 4? None. How many of interval class 5? This one. And how many of interval class 6? None. When we write out the form of an interval class vector, what we do is we list it as the number of each of the interval classes. So we'll start with interval class 1, then interval class 2, 3, 4, 5, and 6. Now, how many of interval class 1 do we have in this set? Just that one. So we'll write a 1 here. How many of interval class 2? This one and this one. So we have 2 of interval class 2. How many of interval class 3? I misspoke earlier. We have this one and that one. So 2 of those. How many of interval class 4? 0. How many of interval class 5? Just the 1. Good look for 5s or 7s there. And so we'll list that one. How many of interval class 6? 0. So when we read an interval class vector, we assume that we sort of remember that those numbers are there. This then is the interval class vector for this pitch class set. One of interval class 1, 2 each of interval classes 2 and 3. No major thirds or interval class 4. 1 perfect fourth or interval class 5. No tritones or interval class 6. Now, just to double check, let's look up here how many intervals are actually in that tetrachord to make sure that we've got them all, just to double check our work. 1, 2, 3, 4, 5, and 6. So we've got the right number of intervals. Now, let's try working with a little bit more complicated example and see if we can make that one make sense. Let's work with a whole tone scale. So the other day, when we were looking at the Debussy Voile piece, we talked about the fact that there are only 2 whole tone scales. One of them has all odd numbers, one of them has all even numbers. So let's use the even numbered one because it starts on 0. 0, 2, 4, 6, 8, 10. Okay? Now, if you remember, the whole tone scale is called a whole tone scale because it's all whole steps, right? So we wouldn't expect there would be any half steps or minor thirds or perfect fourths or anything like that. So let's try collecting or try figuring the interval class vector of this one. Here we start with the original row. Remember, we subtract 0 from everything, and these are the intervals that we get. Now let's subtract 4 minus 2, those two here, right? 4 minus 2 is 2. 6 minus 4 is, oh, sorry, 6 minus 2, I almost made that mistake. 6 minus 2 is 4. 8 minus 2 is 6. 10 minus 2 is 8. Good heavens. All right, next we subtract 4 from everything. 6 minus 4 is 2. 8 minus 4 is 4. 10 minus 4 is 6. Then we subtract 6 from everything. 8 minus 6 is 2. 10 minus 6 is 4. And finally, 10 minus 8 is 2. Now, notice we've got all even numbers in these intervals, which would make sense, right? So let's set up our interval class vector. How many are there of interval class 1? Interval class 1, there are 0. How many of interval class 2? Now remember, we would include 2 and 10 here, because a 10 is the equivalent of interval class 2, because it's 10 is 2 half steps away from 12 or 0 on the clock face. So 1, 2, 3, 4, 5, 6. There's 6 whole steps. That makes sense. Okay. How many major thirds? Interval class 4 or interval class 8? 1, 2, 3, 4, 5, 6. Haha. I forgot to include, there's 0 of interval class 3, right? Okay, here's interval class 4. Interval class 5, ain't none. And then interval class 6, 1, 2, 3. So we look at this, we see that the intervals that are there are only even number intervals. The interval class 2, interval class 4, and interval class 6. So take this and play with it a little bit and see if it doesn't start to make sense with you. I've posted some questions on our help forum for you to practice, and so try answering those questions, and we'll figure it out together. Feel free to email me with more questions. I would actually prefer if you put the questions you have on the help forum, though. Take care. See you later.